I want to go through in this video literal equations. And literal equations are just an equation with one or more variables in them, okay? So our first example here is ax plus bx plus c. Notice that there are no numbers in this equation. A, x, b, and c all represent possibilities, okay? They're all, it's very generalized. It could be any number. So you have to specify with these problems what you're going to solve for. And in this case, I want to solve for x. If you think about it, these equations can be kind of useful. Say you have the formula like c is equal to 2 pi r, okay, which is the circumference of a circle, but you don't want to solve for the circumference. Maybe you have the circumference and you want to solve for the radius. So it would be in your best interest to divide both sides by 2 pi to now have an equation for the radius of that circle, given the circumference. So that's the goal here, is to just be able to manipulate these equations to solve for a particular variable. All right. In this instance, I have two. The problem is x is kind of split. I have an ax plus a bx, and I want to get them all in one. I just want one x in my problem. And I'm going to do that using factoring. If you remember, if you have 2 times x plus 2, you can distribute that 2. Actually, let's make this a 3. You can distribute that 2 into the x and the 3. 2 times x plus 6. Okay, so going this way, that's called distribution. All right, when you simplify it that way. Now, what I notice here is, and maybe another way to write this would be 2 times x plus 2 times 3. What I notice here is that this ax plus bx is very similar to this 2x plus 2 times 3. They both have a 2, right? And it would be nice if I could get it back to looking like that 2 times x plus 3, because that way I would only have one x in my problem. So I can do that. I can just reverse the operation. I can say, okay, well, these two things are equivalent, and switch it back. So that's what I'm going to do. I'm going to pull my x out, or factor my x out, and all I'm going to be left with is a plus b. Right? If we were to distribute that back, it would be identical to this top equation. Right? Is equal to c. Now I just have one more step, and my one more step is to divide by a plus b on both sides. So I'm going to get x is equal to c over a plus b. That's my final answer. On to the next one. Okay, this is very similar. There's just one more added step here. Before I can factor out the x from this top portion, like we did in problem number 1, I have an issue here with this c that I have to take care of. Everything is being divided by c. So in order to undo that, I'm going to multiply both sides by c. Okay, so then we have ax plus bx is equal to 2c. Now it's just like problem number 1. I can factor out an x, be left with a plus b, and then divide by a plus b. Okay. So that's our answer for example number 2. Let's move on to example number 3. So this is, again, like I was saying before, this is the volume of a cone where h would represent the height of the cone. Okay. So I want to solve for h here in this equation. H is being multiplied by three different things: an r squared, a pi, and a 1/3. Now you could solve this all in one step by dividing everything by 1/3 pi r squared. However, I'm just going to do one thing. I'm going to turn this into a two-step problem and just multiply both sides by 3, the reciprocal of 1/3, to get rid of that fraction. I don't want a fraction in the denominator, so I got rid of it by doing that. So now I have 3v is equal to pi r squared h. We just have one more step here. H is being multiplied by pi and r squared. So I need to divide. I need to undo that and divide by pi r squared in order to get rid of them. So now h, we know, is equal to 3 times the volume over pi r squared. That's my answer. So if we have the volume and the radius, we can solve for the height of the cone. I hope these examples helped. Let me know if you'd like more.